let's talk about computer science. If you've ever looked at it and just thought, wow, that is a mountain I am never going to climb, then you are in exactly the right place. Because today, we're not just looking at the mountain, we're unfolding the treasure map that's going to guide you right to the top. And yeah, it's so easy to feel lost, right? There are a million different languages, tools, and weird-sounding concepts. It's totally overwhelming. But what if there was a clear path, a step-by-step guide to take you through it all? Well, that's what we're doing today. Now, this isn't just some random path we made up. The map we're using is the incredible open-source computer science curriculum from roadmap.sh. It's this amazing guide built by developers for developers, especially for anyone who's teaching themselves the ropes. And when I say incredible, I mean it. This isn't just some guide. It's one of the most trusted resources on the planet. It's the 6th most starred project on all of GitHub, with, get this, over 353,000 developers giving it a thumbs up. That's a ton of trust. So let's jump in. Here's what our adventure looks like. First, we'll get our bearings with the adventure map. Then we'll pack our core toolkit, the language and logic. After that, we'll pop the hood and see how computers actually tick. Then we'll get into designing huge systems, working with data, and finally talk about where you go from here. So first up, your CS adventure map. I want you to think about this whole thing not as a class, but as a quest. It's an adventure. Every new idea is a new land to explore, and every little program you build is a piece of treasure. And guess what? Your quest starts right now. All right, section 2, the language and logic. Every adventurer needs tools, right? Well, this is your core toolkit. This is where you learn to speak the computer's language and understand the basic logic behind everything. And by the way, this section right here, this is what pretty much every single coding interview is all about. First thing in the toolkit, data structures. I know, it sounds super technical, but don't let the name fool you. It's simple. Think of a video game. You have an inventory, right? It holds all your stuff. Data structures are basically just that. They're the inventory system for your code, specialized containers to hold information. And check out how simple this can be. Let's take 2 of the most basic data structures. A stack is just like a pile of plates. The last one you put on top is the first one you take off. A queue is literally a line at a store. First person in line is the first person to get served. See? You already get the logic. Next up, big O notation. Okay, this one sounds really scary, but it's not, I promise. It's just a way to talk about how efficient your code is. It's not about seconds or minutes, it's about how your code's performance changes as you throw more and more data at it. It's how you prove your code is fast and smart, which is why interviewers love asking about it. Look, the absolute best way to make this stuff stick is to build something. So here's a perfect starter project. Build a simple contact book. It makes you think about how to store names and numbers and then how to sort and search through them. And once you're done, put it up on GitHub. Boom! That's the very first piece of your professional portfolio. Okay, so we've got the logic down. Now let's move on to section 3, how computers work. We've talked about the software, the code. Now it's time to actually look under the hood at the machine itself. Seriously, understanding this stuff will give you a huge leg up. Let's start with computer memory. Think of RAM as your workbench. It holds everything you're currently working on, all the apps, all the files. Then you have the CPU cache. Think of that like your pockets. It holds the 1 or 2 tools you need, like right now, for immediate access. It's all about making things faster. And what about the internet? How does that even work? Well, a huge piece of the puzzle is something called DNS. And all it is really is the internet's phone book. When you type in a website, DNS looks up its actual address, the IP address, so your computer knows where to go. It's the very first step of you seeing pretty much any website. So you get the logic, you get the machine, but how do you go from building a tiny little script, like a small hut, to building something massive, like a sprawling castle? You know, something like Netflix or Google that millions of people can use at once. Well, that brings us to section 4, designing large systems. When your app gets really popular, you have to scale it. And there are 2 main ways to do that. Vertical scaling is like making your castle bigger and stronger. You just get one much more powerful computer. Horizontal scaling is like building more castles. You add a bunch more computers to share the work. Okay, but if you have a bunch of servers, how does the internet know which one to send a new user to? That's what a load balancer does. It's basically a traffic cop for the internet. It sees new requests coming in and directs them to the server that's least busy. It's absolutely essential for keeping a big website running smoothly. Let's move on. Section 5, working with data. You know, at the core of just about every app out there is data. User profiles, products, photos, whatever. How you store that data and get it back out again is super important. It's like organizing your application's treasury. When it comes to storing data, you'll mainly hear about two big families of databases. SQL databases are really structured, kind of like a spreadsheet with very strict columns. NoSQL databases are way more flexible, more like a folder full of Word documents. They both have their pros and cons, and knowing which one to pick is a really valuable skill. Want to put this all into practice? Try building a simple search engine. You'll have to set up a database to store articles and then write the logic to index them and search for words. It's a challenging project for sure, but man, talk about an impressive thing to show off to a future employer. And that brings us to our last section. The journey continues. Learning all this stuff, it's not a race. There's no finish line. It's an ongoing journey. And sometimes you're going to feel stuck or burnt out. But the most important thing to remember is that you are not on this path alone. The community that's grown around resources like roadmap.sh is just huge. I mean, their Discord channel has over 46,000 members. That is an army of other learners and pros who are there to help you when you're stuck, cheer you on, and just get it. So, let's wrap this all up. What's the plan? First, start with the fundamentals, data structures and algorithms. They are the key to everything, especially interviews. Second, build projects. Apply what you learn and build that portfolio. Third, understand the machine. Fourth, don't shy away from the big picture ideas. And last, but maybe most importantly, find your people. Find a community. As you get started, just keep this in mind. It's a quote from the legendary B.B. King. The beautiful thing about learning is that nobody can take it away from you. Every single concept you figure out, every line of code you write, that's yours. It's an investment in yourself that will pay you back forever. So there you have it. The path is laid out. That feeling of being overwhelmed, hopefully it's been replaced by a clear step-by-step guide. The only question left is the fun one. You have the map. What are you going to build first?